Okay. So for the following circuit, find the, okay, this is important. Potential difference between nodes A and B. Okay. So as you know, when you have a circuit, any point will have a potential. This potential could be in with respect to a reference. Okay, but it has a potential. But we can also look at potential difference, meaning that, for example, I look at when we say plus and minus, for example, V1. So what we are saying basically is what's the difference between potential of this point and that point. Okay, so we had seen this before. Also, we might look at different nodes in a circuit, for example, node A and B, and still we can say, what is the potential difference between node A and B? Okay. So in that case, let's call it VAB, actually. Let's call it VAB. Okay, so it means that if, for example, we have VA here and we have VB here, basically the potential difference, VAB, is nothing but just VA minus VB. The difference between their potential. So this is the potential for node A, VA, this is the potential for node B, and then this is the potential difference. Okay, VAB is potential difference. Okay. And okay, so in this circuit, we want to find the potential difference between node A and B and then node C and D. Okay, that's fine. By looking at the circuit, it's just one loop we can do, and we have a current source. Okay, so somehow we know the current in the loop. Okay, so there's a loop, there's a current. 1 amp is going through the, see, 1 amp is going through the circuit here. The whole circuit has 1 amp. So all the elements will have 1 amp, 1 amp, 1 amp, 1 amp, 1 amp, and 1 amp. Okay. So for all of them, 1 amp. And again, why is that? Because as you see here, this 1 amp is coming here. And the current here is 0. There is no connection here. As you see, it's just open. It's open, so there's no current going down that way, left. So all the current goes to the right. So the whole 1 amp goes to the circuit. Okay, so knowing the current, and we also know the value of the resistance, so we can basically just know the potential for each of them. Okay. So let's do this. So what is the potential? I write it with green. So if this is 2 ohm and it's 1 amp, so therefore this is 2 volts. This is 3 volts. This is 2 volts. This is 4 volts. And did you notice that when I put plus and minuses, because the current is going this way, 1 amp is going this way, I'm putting the plus here, plus and minus. Plus and minus 4 volts. So, and this is a passive sign convention. Okay. And the same here. This is also 1 amp is going that way, plus and minus 1 volt. Okay, so we have this. Now we want to find the VAB. Okay, so we can do a KVL on this part. Okay, so although A and B are not connected, it's just we put a potential, but it's still the summation of the potential have to end up to 0. So this is the basically point of this question. So I start from here going up, negative VAB, and then to the right, plus 3, plus 2, and plus 4 equal to 0. So VAB is 3 plus 2, 5 plus 4, 9 volts. Okay. So again, you can see this different ways. So I write it here again. We had the 3O, we had the 2O, we had the 4O, and I'm looking at this potential difference. And 1 amp is going over this, the whole thing. Okay, so somebody could say, okay, you know what? I have, what is the resistance here? 2 plus 3, 5, and for 9 ohm times 1 is 9 volts. Okay, you can just say 9 volts by just that. Okay, or you can just do KVL as I did in the top. So negative VIB plus 3 plus 2 plus 4 volt equal to 0. VIB is 9. Okay. So you can easily find potential difference this way. Also, the part B says that find the potential difference between nodes C and D. Okay, we can do that too. So now we go to this node and we're looking for this potential difference between the potential of node C and D, VCD. Okay, so again, we can do the same thing. We can either say that okay, so somehow I'm gonna extend this. So you had another 2, you had 1, you had 1 amp, and then I'm looking for this voltage, VCD, plus and minus. Okay, so you can do a KVL around again this. Negative VCD plus this was 2 volt, 3 volt, 2 volt, 4 volt, and 1 volt equal to 0. So VCD is 2, 3, 5, 6, 7, 11, 12. Okay, so this is the concept of potential difference. You have two nodes, you just put plus and minus, and then you can write a KVL, for example, to find the potential difference. Okay, now there is another part C, that it says now we connect a resistor R equal to 12 ohm between terminals C and D. Now, what is the current in that resistor? Yeah. So because this circuit somehow got very crowded, let's copy paste it again here. So part C says I connect R equal a resistor of R equal to 12 ohm, and you would like to find, let's call this I1. What is I1? Yeah. I would like to do this through current division, okay, because we have a current source. So let's do that as a practice too. So I had the 1 amp here, and on one side we have this 12 ohm. This is R1. And then the other side we have 2, 3, 5, 6, 7, 11, 12. Okay, we have another 12 ohm here. Okay, so let's call this, for example, R. This is call it R. I don't know, 2. Okay, and the 1 current source and 2 parallel resistor. Okay, so remember, it doesn't matter, it looks like this, the current division, R1, R2, it looks like this. Both of them are current division. So this is I1, I2, or this is I1, I2. So basically they're the same, exactly the same. It's just a different drawing of the same circuit. Okay, so for both, all of them, if you, as you recall, I1, when you have 2 resistors, the formula becomes I1 becomes R2, the other resistor, divided by R1. plus R2 times the amount of the current which is coming. And I2, this one is R1 divided by R1 plus R2 times R. Okay. Now that's it for this circuit that we have. I1 is 12 divided by 12 plus 12 times 1 amp. So this is 12 divided by 24, which is half. So we get 0.5 amp. I1 is 0.5. Okay. And one other way of saying that is because these two resistors are equal, therefore the current will equally be divided with this one. This is just a special case. It doesn't apply all the time, but here in this case, because both of them are 12 ohm, so for everything should be divided equally. So half of the amp goes here, half of amp goes there, or you can go from the formula.